G'day everyone, you're watching Kath with a K, and I'm Kath. I make music videos, songwriting challenges, and also talk about science news and the climate. So if any of that interests you, you should subscribe and hit the bell so that you get notified every time I post a video, which is every Monday. And with that, let's get into the topic of today's video, which is how do emissions from different types of vehicles compare to one another? I got the idea for this video because I recently bought a motorbike, and a couple of my friends asked me why I would buy a motorbike if I was so invested in being environmentally friendly. And I was like, what do you mean? It's replacing a car? And it turned out that they were under the impression that motorbikes are actually worse for the environment than cars. And I was quite surprised because I thought that it was fairly common knowledge that motorbikes are way better than cars in terms of their fuel efficiency. So I posted a poll on my Facebook page a few days ago asking you to vote on whether you thought a car was more environmentally friendly or if a motorbike was more environmentally friendly, given that they both had just one person in them or on them. And I got one person saying that a car was better and 3 people saying that a motorbike was better, which doesn't really tell me much because a sample size of 4 isn't exactly super great. So follow my Facebook page so that I can have larger sample sizes in the future. I think that a really simple way to explain why a motorbike would be so much more fuel efficient than a car would be to go back to high school physics. We all learnt, right, that force equals mass times acceleration. Now, when you've got a car and a motorbike, let's say the acceleration is about the same. Mass, well, you can just look at a car and then look at a motorbike, and I think you can pretty easily guess which one is going to be heavier than the other. So I actually looked up the weight of cars versus the weight of motorbikes, and cars will weigh somewhere between 1,200 kilograms to 2,000 kilograms, and a motorbike will weigh between 100 kilograms and 400 kilograms. From the equation F equals ma, you can tell that you're going to have a lot less force needed for a motorbike than for a car, and the force in this case comes from the energy being burnt by the fossil fuel inside the vehicle. I wanted to find out more exact figures for comparing these two vehicles, but I also got more interested in the sustainability of different types of transport. And you know, people always have this idea of, well, public transport is always going to be better, but like, how much better is it? The first thing I need to mention before comparing different vehicle groups is that within each group there's going to be a wide range of fuel efficiencies. And if you've looked into buying a car before, you probably know all about this. Some cars will go like 20 miles per gallon and some cars will go like 50 miles per gallon. And these ranges exist in all vehicle types, including motorbikes and even planes, which I never even thought about before. So I tried to calculate the average carbon dioxide emissions per kilometre for each of these vehicle types that I'm going to get into. I looked at cars, electric cars, motorbikes, buses, and planes. But the vehicle that you have at home or the public transport that you have in your country will probably vary from the average, but hopefully this will still give you a good idea of like what to expect from the average of each type of vehicle. First, let's look at cars. I found a guide from the US, which was a car fuel economy guide for 2020 model, and I only looked at car types that were listed as compact, mid-size or large because I wanted to narrow the range. There were like all sorts of, you know, pickup trucks and 2-seaters. This gave me just under 400 vehicles with all sorts of different fuel efficiencies, and I felt that the most relevant average to look at was the mode, and for cars there was 26 miles per gallon. Now I translated this to 90.5 milliliters per kilometre, and since most cars use petrol instead of diesel or some other kind of fuel, I used the figure for petrol carbon dioxide emissions, which is 2.31 kilograms per litre. So from these figures, the average car would emit 209 grams of carbon dioxide per kilometre. Let's look at motorbikes next, since that's what started this all. The most recent database of motorbikes that I could find that actually had a large number of motorbikes to get some sort of average from was from 2016 models. So fuel efficiency might have improved a little bit since then, but hopefully it's relevant enough. Excluding the models that had less than 125 cc of engine power, because who is riding something like that? I feel like they probably included scooters in this list. There were 200 models of motorbikes and the average fuel efficiency was 42 miles per gallon. Now I would like to note that while the mode was 42 miles per gallon, the mean fuel economy was actually much higher. So it seems that there are going to be some motorbike models that have a much better fuel efficiency than others. This translated to 56 milliliters per kilometre, and using the same value from petrol emissions as before, the average motorbike emits 129 grams of carbon dioxide per kilometre. Now, having said that, there are ways to reduce the emissions that your car or your motorbike produce. There are now ethanol blends like E10 or E15 available at a lot of different servos. The higher the number after the letter E, the higher the ethanol content, and the ethanol is made from plants like sugarcane. I must say I didn't really quantify the difference in emissions between all the different things that are available. I just looked at straight petrol, but maybe someone else has done a video about that, or maybe I'll do a video about that in the future if you're interested in that. I'm interested in that, so I'll probably end up doing a video about it at some point. But remember to check your car manual to see, what concentration your car can actually handle without having some sort of conversion. There's also a more environmentally friendly version of diesel called biodiesel. This is made of vegetable oils and animal fats, and it's sometimes blended with diesel to create a more environmentally alternative for it. Now let's move on to electric cars. I'm sure you've heard all sorts of things about electric cars are only, helpful in certain parts of the world, and it really depends on where your electricity from, which is true. But what kind of carbon dioxide emissions can you actually expect from electric cars? Now, one thing that comes up a lot is that the production of the batteries for electric cars use fossil fuels that you don't need to use in the creation of regular cars. And that is true. I found some figures for the difference in the manufacturing emissions in a case study of 4 different cars, which showed that a mid-size electric vehicle had approximately 1 more US ton of carbon dioxide emitted in manufacturing than a petrol-based mid-size vehicle, while the large electric vehicle had approximately 6 more US tons of carbon dioxide emitted in manufacturing. This case study also assumed that the mid-size vehicle was driven 217,000 kilometers over its lifetime, and the large vehicle was driven 288,000 kilometers over its lifetime. So if we calculate how much this translates to in terms of grams of carbon dioxide emitted over a kilometer, over the course of a car's lifetime, for a mid-size electric car, the extra manufacturing emissions translate to 4 grams of carbon dioxide per kilometre. And for a large electric car, they translate to 19 grams of carbon dioxide per kilometre. Now, of course, there are the emissions of producing the actual car itself, which are, according to this study, about the same for an electric vehicle and a regular petrol-based vehicle. But excluding the manufacturing of the rest of the car, the bulk of the car, given that the average car emits 209 grams of carbon dioxide per kilometre, the manufacturing of an electric vehicle adding an extra 4 to 19 grams per kilometre doesn't seem like that big of a deal, to be honest. The most important thing for electric vehicles is where your electricity comes from. And this is why people say that in Australia, electric vehicles don't really have much point to them, because Australia gets 90% of its electricity from coal and natural gas. Oh shit, sorry, I meant to say 80%, but this does differ by state. I found an emissions calculator on powershop.com.au for Australian states, and I'm assuming that most of the people watching this are from Australia. If you're not, then you can look up the emissions factor for your region. But each state has an emissions factor, which is the kilograms of carbon dioxide that are emitted per kilowatt hour of electricity use. My state of Victoria actually has the worst emissions factor out of all of the states in Australia, coming in at 1.07. So if so much of our electricity is coming from fossil fuels, can electric cars actually be good in Victoria? The US Fuel Economy Guide for 2020 also had electric vehicles in it. They had about 20 in the categories that I picked standard vehicles from before. I just want to mention that I do feel like the US guide is relevant to Australia because given given globalization, there isn't going to be much difference between which cars are being sold in the US and which cars are being sold in Australia. The average for the electric vehicles was 113 miles per gallon equivalent, and the equivalent of a gallon that they're using here is 33.7 kilowatt hours. This means that the average electric car uses 185 watt hours per kilometre, not kilowatt hours, watt hours. In the state of Victoria, the emissions factor is 1.07. So in Victoria, an electric car using the just standard grid electricity would emit 198 grams of carbon dioxide per kilometre. When I add these values to my graph, I won't be including the manufacturing emissions because I don't know the manufacturing emissions for all of the different types of vehicles that are here. And also I don't know the battery size for all of the different electric vehicles that were in the fuel economy guide. So I wouldn't even know which value to use, but maybe keep this in mind for, if you're looking for an electric vehicle. And I've put together a graph showing how many grams of carbon dioxide will be emitted per kilometre for your electric car for all of the different states in Australia. As you will see, Tasmania is by far the best with an emissions factor of only 0.19. I'll leave a little equation in the description for you to be able to calculate how much the average electric car would emit in CO2 using the emissions factor for your own area. Something that I forgot to mention while filming is that there are power providers that offer 100% clean energy or a greater percentage of clean energy than what is currently available in states like Victoria. So these emissions would be greatly reduced when you're powering your vehicle with electricity from those clean sources. As I mentioned before, every vehicle within a certain group of vehicles has a different fuel economy, and this is the same for planes. For example, British Airways planes are up to 51% less fuel efficient than Norwegian airplanes. These companies aren't super applicable to Australians, but it just goes to show that you might want to check the fuel economy of the flights that you're getting, with many websites now such as Skyscanner letting you know which of the trip options have less carbon dioxide emissions. So definitely consider looking at this when you just have to get a plane to somewhere, like let's say you're going to Europe to meet your family, which is something that I definitely do every few years. I looked at a study that showed the most common plane models for different flight lengths that investigated how much they emit over a flight. On average, a short flight emitted 120 grams per kilometre per passenger, and a long flight emitted 140 grams per kilometre per passenger. The reason that this is larger for longer flights is because longer flights use planes that are much bigger and heavier. Now, you will have noticed that these carbon dioxide emission figures are significantly smaller than the cars that we investigated earlier. But aren't planes so much worse than cars? So how can it be that they emit less carbon dioxide? Well, the emissions from planes trigger other chemical processes that also have warming consequences. So planes contribute more than just the carbon dioxide that they emit. They also emit nitrogen oxides and water vapor. Nitrogen oxides form ozone in the presence of light, and there's a lot of light in the area of the atmosphere that planes fly at. Ozone is a very potent greenhouse gas, and it's even more potent than carbon dioxide. Although ozone does also destroy a bit of atmospheric methane, which is also a greenhouse gas, overall it has more of a warming effect than whatever it takes away from the methane concentration. Planes also emit water vapor, which form things that look like clouds, which most people know as contrails, but I'm sure that some people watching this video will know them as chemtrails. These trap heat in the atmosphere, and their warming effect is believed to be equal to that of carbon dioxide, but the water vapor doesn't last as long as carbon dioxide does. It actually fades away fairly quickly. A report on aviation carbon dioxide emissions by Climate Care suggested using a multiplier of 2 on the carbon dioxide emissions of a plane when trying to compare them to other vehicles because of all the extra effects from being so high up in the atmosphere. Different papers have come up with different values ranging from between 1.9 to 2.7, but I'm not like an atmospheric scientist or whatever, so I'm not going to come up with my own value. I'm just going to use the value that they gave me, and with the multiplier that becomes 240 to 280 grams per kilometre. The last thing to talk about is public transport. I didn't actually manage to find a lot of information about buses that were specific to Australia, but I did find a website called Carbon Independent that had figures for London buses, and they suggested that a London bus emits 822 grams per kilometre. Now, of course, on buses you usually have a lot more than just one passenger, so this decreases drastically once you have a full bus. But of course, this is only one figure for buses. I don't know how it would be different for the buses in Australia, let alone buses in other countries. This is my completed graph for all of the transport methods that I investigated, specifically for Victoria when we're looking at electric cars. And remember that just because a difference looks small on this graph, that doesn't mean it's going to stay small over larger distances, because you usually travel many kilometers on each journey that you make, not just 1 kilometer. I'm also interested in the amount of carbon dioxide that trains emit, and I'm sure that you might be interested in that as well. I actually couldn't find very much information on this. I found many sources that said that they per passenger emit many times less carbon dioxide than your average car, but I didn't really get specific numbers anywhere. I managed to find some figures for how much electricity metro trains in Melbourne uses every year, because metro trains are electric, but that doesn't really help with a per kilometre figure because I have no idea how many kilometres of travel that translates to. The only thing I managed to find was this graph, which showed that trains are significantly less polluting than other forms of transport. So although I don't have any specific numerical values, it does seem that trains are the way to go for public transport, but people are probably doing that anyway because trains are much faster than buses. I hope you enjoyed this video and that you learnt something about the emissions from different sorts of vehicles. Let me know what you thought in the comments, or if you want me to look at any related topics in the future. Bye!